Welcome to another physics video. Our topic today is simple electric circuits. This video will focus on series circuits. The key idea behind all circuit analysis is that all parts of a circuit must obey Ohm's law. So, we will monitor current, voltage and resistance and try to see how it works for a circuit, instead of just one light bulb. To make a circuit we must have an energy source, like a battery or a power supply, and something to use the energy, like a light bulb. Let's take a look at a circuit. The first part of the circuit we need to look at is the battery. It is represented by a long line and a parallel short line. The long line is the positive side of the battery. So, current will leave the battery going away from the long line and return coming towards the short line. The next element of our circuit is any device that will use the energy that the battery provides. We will represent devices by the value of their electric resistance. Right now, this resistor has a value of 0 ohms, so it is like it is not here. The same is true for the third resistor. Since its value is 0, there is no resistance here. We can measure the voltage across any element in our circuit using a voltmeter. The voltmeter measures the difference in electric potential between the two places where it is connected. It does this without changing the current passing through the circuit. Right now our circuit contains only one resistor. Notice that both the resistor and the battery obey Ohm's law. The voltage is the product of current and resistance. The resistance value we use for the battery is called the equivalent resistance of the circuit. It is the combined resistance value of all the devices in the circuit. Since our circuit only has one device, the equivalent resistance is the same as the value for the single resistor. Now that we have looked at the various pieces of a circuit, let's take a look at one with two devices connected. This circuit contains two devices, represented by resistor number 1 and resistor number 2. Let's see if we can see any patterns in the values of current and voltage. Notice that there is only one path for current to follow as it flows through the circuit. It leaves the battery in a clockwise direction, passes through resistor number 1, passes through resistor 2 and then goes back to the battery. At all locations in this circuit, we have the same current value. In this case it is 1 amp. This is because there is only one path. We call this a series circuit and its most important feature is that the current has the same value everywhere in the circuit. Notice that the equivalent resistance of the circuit increased when we added the second device. This caused the current in the circuit to decrease. It looks like the equivalent resistance is the sum of the resistance values of our two devices. We'll have to watch and see if this pattern continues. Let's add a third device to the circuit. The two patterns continue with a third device. We now have even less current than the last circuit, but it is still the same value everywhere, and the equivalent resistance increased by 15 ohms, which is the value of our third device. Now, let's look at the voltage values. The battery provides 30 volts for us to use. Each device, because they are all identical, uses 10 volts. This is an additional feature of a series circuit. The battery voltage is divided between the devices. It doesn't have to divide evenly, as we will see in the next circuit. This circuit only has two devices. Notice that resistor number 1 is twice as much as resistor number 2. Now notice that the voltage for resistor number 1 is also twice as much as the voltage for resistor number 2. The combined voltage is still 30 volts, which is what the battery is applying. Let's summarize what we have learned about series circuits. It is called a series circuit because there is a single path and the same current flows through each item. They are connected one after the other to form the circuit. Because the current is the same everywhere, the voltage provided by the battery is divided between the devices. The equivalent resistance of a series circuit is the sum of the resistance values in the series. Just add them all together. If we have a series of light bulbs in a circuit and we add more bulbs, all of the bulbs will not be as bright as before because there is less current in the circuit. And, If one bulb in a series goes bad, then all bulbs will shut off. This is because there will be no path for the current to flow through the rest of the bulbs. That's it for series circuits. We'll meet again to discuss parallel circuits.